This is the Milestone 3 final presentation. I am Ezra Prophet, and here are my coworkers.
My name is Luke Jenquin.
I'm Matthew Cedor.
And I'm Teddy Dano.
All right, let's get started.
The ability to hear oncoming emergency sirens may seem normal and unimportant to most people, but to those who are deaf and hard of hearing, it is a major hindrance to their situational awareness while driving. The vibrational alarm system for public emergency vehicles, VASPEV, would solve this problem for those with hearing disabilities by utilizing a system that can be implemented into any type of vehicle, smartwatch, or mobile phone. The VASPEV would then be paired with the emergency vehicle locator to identify when any active emergency vehicles are within a certain range, and then proceed to release a warning to the user through a vibration of the steering wheel or other device. These vibrations will vary in intensity depending on how close an emergency vehicle is to the device installed with the VASPEV.
Approximately 1 in 20 Americans are currently deaf or hard of hearing, and nearly 1 million Americans are functionally deaf. People who are listening to noise cancellation headphones, using hearing protection, or experiencing loud ambient noises will also experience a temporary disability similar to being deaf. These people with disabilities are primarily relying on optical and tactile feedback to be aware of their surroundings. So being tapped on the shoulder or being waved at to get their attention. And a VASPEV solution would allow its users that are hard of hearing to be aware of emergency vehicle sirens and to actively seek to preemptively avoid any confusion or collisions with the same theory. VASPEV is designed to help people who are deaf, situationally deaf or hard of hearing, know when there are active emergency vehicles that are within a certain area of them. It will notify the VASPEV user through the vibration of a connected device or steering wheel attachment. These vibrations will vary in intensity based on the location of the emergency vehicle relative to that of the device with the VASPEV installed. This should then allow drivers, runners, workers, or other people with hearing complications to have more situational awareness, which will ultimately provide them and emergency vehicle operators rushing towards situations safer conditions.
So there are two primary challenges that the VASPEV is related to. First off is engineering better medicines. We are using technology to help make up for people's auditory impairments. So essentially, technology is being used as a treatment option and acts as a substitute for more traditional medicines. Second off, we have advancing health informatics. By using VASPEV, we can hopefully gather even more data about how hearing loss can affect driving. More data will then allow us to learn even more about deafness and develop even more ways to alleviate its impacts.
VASPEV could or would be paired with a device similar to the emergency vehicle locator. The associated device detects emergency vehicles within the general proximity of the driver's car. VASPEV will alert deaf drivers through vibrational warnings, in which intensity and duration of the vibration depend on the proximity of the emergency vehicle. Duration of vibrational alerts will continue as long as the emergency vehicle is within a radius of 100 meters of the driver. Intensity of vibrational alerts will increase every 20 meters as the emergency vehicle approaches the driver and vice versa as it passes. Lowest intensity will be just noticeable, and the highest intensity would be equivalent to a rumble strip. As you can see here, the radius of this largest circle is 100 meters. Every 20 meters, it increases in intensity and duration. As you can see here, it starts to be more dangerous for the driver as the emergency vehicle approaches them, as your detection from light blue to green to yellow to orange to red.
So our marketing plan, how will it be advertised? Well, VASPEV will be marketed as a safety app that will notify people of oncoming emergency vehicles. Ideally, we will get a sponsorship or some kind of support from the National Association of the Deaf, although that is not guaranteed. Where will people be able to get it? It will be available for download on the App Store and the Google Play Store for any smartwatch or for their mobile phones, but the VASPEV steering wheel extension will have to be purchased separately. Who should use it? It can be used by anyone. Deafness of different severities are experienced by everyone, whether it be permanent or temporary, as we've already discussed. So, therefore, most people will be able to get some kind of use out of it.
The shortcomings. The main shortcoming with the VASPEV system is that it centers around the inability for the active emergency vehicle to tell where the active emergency vehicle is approaching from. Since the VASPEV system is set up to vibrate when the vehicle enters within a 100-meter radius, the person using it will not only know that the emergency vehicle is nearby without knowing its exact location. With the current design, it is impossible to tell someone to tell if the vehicle is approaching them from their front, rear, or side without seeing it first. This may cause some confusion for the person using the system. And then the other one is a reliable connection. The other main shortcoming of the VASPEV system is that it will only work if there's a reliable connection between the active emergency vehicle, the emergency vehicle locator, and the VASPEV system. If there's not a reliable connection, then the VASPEV system will not work properly to alert the person of using the system of an incoming active emergency vehicle. This shortcoming may be detrimental due to the fact that the person using the system will most likely not be fully alert of their surroundings, since they'll be relying heavily on the system to tell if there is an active emergency vehicle approaching them.
For feasibility and the next steps of our idea, finding a way to finance this new app product would be an obstacle in the way of implementing it into cars around the world. But in all business risks, there is a leap of faith, and finding sponsors, business partners, and reasonable loans would only be the beginning. We will need a very intricate and professional design to be able to sell the idea to not only the public, but to potential business investors and partners. Better designed programs, expensive tools, and the actual location for the production of the device would be needed. Even with automation, production takes time, money, space, and especially workers. Finding, paying, and even hiring more employees would have to be feasible for us as new entrepreneurs in order to bring this product to the shelves. We have our works cited here, and that is the end of our presentation.